In this video, we will learn to solve 10 questions. The book is Concepts of Physics, Volume 2. The chapter is Electric Field and Potential, and the writer of the book is Shree H C Verma. Question number 1 is find the dimensional formula of epsilon naught. As we know, the epsilon naught is the permittivity of air or vacuum. To get the dimensional formula of epsilon naught, we must know the dimensional formula of force, the dimensional formula of any number, and the dimensional formula of charge. As we know, the formula of the force between 2 point charges is 1 by 4 pi epsilon naught q1 q2 upon r square. By exchanging the value of F by epsilon naught, we can get the value or the formula in terms of epsilon naught. We will be writing the dimensional formula of each and every physical quantity present in right hand side, and after adjusting the power we will be able to get the dimensional formula as m minus 1, L minus 3, T4, I2. Question number 2 is saying that there are two charges, each is having a magnitude of 1 coulomb, are placed at two different locations. First, your college building, second one is at your house. And the distance between these two is taken as 2 kilometers. Then we have to calculate the force between these two, and then we have to compare this force of your weight. So let us first consider that a person is standing on a weighing machine having mass 50 kg. Weight will be obviously equal to mass into acceleration due to gravity. G, if we are taking 9.8, it will be 490 Newton. This we will compare once we calculate the force between these two charges which are present at your house, on the top of your house, and at the top of your college. The distance is given as 2 kilometers. Again, we will be using the same formula as Coulomb's law. We will be putting all the values as 1 by 4 pi epsilon naught is taken 9 into 10 raised to 9. Q1 is 1, Q2 is 1, and distance is 2 kilometer. We need to change 2 kilometer into meter, that is 2 into 10 raised to 3. Then after calculation or simplification, it comes as 2.25 into 10 raised to 3 or 2050 Newton. Once we compare with your weight, it will be 2050 upon 490. The force will be repulsive in nature. Question number 3 is asking about distance. That at what distance two equal charges of 1 coulomb each be placed so that the force between them equals to weight of a 50 kg person. Again, weight of 50 kg person we are going to have as 490 Newton. Weight is nothing but force applied by earth on human body. Now these two charges are placed at a separation of suppose r that we are going to find. So let us use the formula again given by Coulomb's law, that is 1 by 4 pi epsilon naught q1 q2 upon r square. From here again, if we are exchanging r square by f, it is r square is equal to 1 by 4 pi epsilon naught q1 q2 upon f. Put the value 9 into 10 raised to 9 as 1 by 4 pi epsilon naught. Then q1 is 1, q2 is 1, f is 490. After calculation, we will be able to get the value of r as 30 upon 7 or 4.285 into 10 raised to 3 meter or 4.3 kilometer approximately, or 4.285 kilometer. Exact value will be there. Question number 4 is saying again two equal charges are placed at a separation of 1 meter. The distance is given. What should be the magnitude of the charges so that the force between them equals to weight of a 50 kg person? Again, we are using the 490 Newton. Here we have to calculate the charge. We will be using the same formula given by Coulomb's law, and that is q square is equal to 4 pi epsilon naught r square into f. 4 pi epsilon naught value will be 1 by 9 into 10 raised to 9. R is 1 meter, so 1 square, and then 490. After adjusting the power, we will be able to get 7 upon 3 into 10 raised to minus 4 or 2.33 into 10 raised to minus 4 coulomb. That is the amount of charge. Question number 5 is saying that there are two protons separated by a distance of 1 Fermi. 1 Fermi is nothing but distance between two protons which are residing inside a nucleus. And this is the reason, this is the distance actually at which protons, or the nucleons to be more precise, are present. We need to calculate the force. We know that proton is having a charge, a positive charge of 1.6 into 10 raised to minus 19 coulomb. Take distance as 1 Fermi, apply the same formula, put the value, standard values like 1 by 4 pi epsilon naught q1 q2 upon r square, and after calculation we will be able to get the value of force between these two protons as 230.4 Newton. Obviously it will be repulsive in nature. In question number 6, it is saying that two charges are placed at certain separation, and we have to find a position of a particular point where if we are going to place a particular charge would experience zero force or no force. So here we will be applying the formula of electric field, that is, field due to a point charge is nothing but 1 by 4 pi epsilon naught q upon r square. These are two charges placed at 10 centimeter separation. We are going to take a particular point P at line joining the charges, which is at a distance of x from q1 and obviously 10 minus x from q2. Let us now calculate total field at particular point P. To be more precise, it will be equal, and it must be equal in magnitude, opposite in nature. Then only if any charge we are going to put at particular point P, it will experience zero force. So formula of field due to q1 at point P is this, point Q is this one. We have not changed here centimeter into meter. Even if we are going to change, it will be 10 raised to minus 4 multiplier and will get cancelled because we are going to compare the formula on both the sides. Then q1 upon x square is equal to q2 upon 10 minus x the whole square. We are going to have the value over here of q1 and q2, and we will be getting this value, 2 by 1 is equal to x square upon 10 minus x the whole square. After more simplifying, we will be able to get this value. After cross multiplication, we will be getting this value. Take the value of root 2 as 1.414 and we will be able to get this value as x is equal to 5.86 centimeter from the bigger charge. And you can take 10 minus this value from the smaller charge. Question number 7 is taken from the previous question, that suppose the second charge in the previous problem is minus 1.0. So if both the charges are going to be opposite in nature, like one is positive, another one is negative, there is no point on line joining the charges in between these two charges where field would be zero. In that situation, we need to consider the point outside, like this P here we have taken nearer to negative charge. Why we cannot take it nearer to the positive charge? Because positive charge is having bigger magnitude than that of negative charge. So there is no chance that nearer the bigger charge the field is going to be zero when it is going to encounter with a charge having less magnitude and present at further distance. So P here we are going to consider a particular point charge Q having at a distance r centimeter from Q2 and obviously 10 plus r from Q1. Force due to Q1 will be away because it is positive and Q is positive, repulsion will be there. Force due to Q2, which will be towards the charge. Field, if it is going to be zero at particular point P, both the directions are opposite and they must be having same magnitude. So once we put the value of the point charges or force between these two point charges, 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught will get cancelled, Q and Q will get cancelled, and again we will be getting the value as Q1 upon Q2 is equal to 10 plus R upon R the whole square. Put the value once again, we will be able to get 2 by 1, and after removing the square sign it will be root 2 by 1, 10 plus R by R. Cross multiplication, it will be root 2R is equal to 10 plus R. Taking the R other side, subtracting value after, it will be 0.414 R is equal to 10 centimeter, or R is equal to 24 3.15 centimeter. From the smaller charge, if we want to calculate from Q1, we can add 10 centimeter, so it will be 34.15 centimeter. Question number 8 is saying two charged particles are placed at a distance 1 centimeter apart. What is the minimum possible magnitude of electric force acting on each charge? So force will be minimum when charge on the particle is going to be minimum, because distance is already given, and we know that charge is minimum, that is 1.6 into 10 raised to minus 19 coulomb. They may be positive, they may be negative, both may be positive, both may be negative. So it may be attractive in nature, it may be repulsive in nature. Using the Coulomb's law, putting all the values, we will be able to get net force as 23.04 into 10 raised to minus 7 Newton. It may be attractive or may be repulsive. Question number 9 is saying that estimate the number of electrons in 100 gram of water. Again, in this question we are going to use small amount of knowledge or small amount of application from chemistry, that is number of mole and how to calculate the number of mole. If you're talking about water, its chemical formula is H2O. If you're talking about the molecular weight, it is 2 from hydrogen side and 16 from oxygen side, so it will be total 18 gram. If you want to calculate the number of moles present of water in 100 gram of its weight, it will be 5.56, that is 100 upon 18. If we talk about total number of H2O molecules, we must multiply the mole with the Avogadro's number, that is 6.023 into 10 raised to 23. Now one H2O is containing 10 electrons, so total number of electrons we have to multiply 10 with the total number of molecule, and it will be 3.35 into 10 raised to 25 electrons. We know that one electron is containing a negative charge of 1.6 into 10 raised to minus 19 coulomb. So total charge or total negative charge on the electrons present in 100 gram of water would be multiplied by 1.6 into 10 raised to minus 19 coulomb with the total number, and we will be getting 5.36 into 10 raised to 6 coulomb of the negative charge. In the question number 10, it is saying suppose all the electrons of 100 gram water are lumped together to make a negative, all protons in the nucleus are taken together to make positive charge, then find the force between these two if they are present at 10 centimeter. Again, 10 centimeter distance. From the previous question, we will be taking the charge, that is 5.35 into 10 raised to 6 coulomb, and these are the two charges, 5.35 into 10 raised to 6, 5.35 into 10 raised to 6, positive and negative, distance is 10 centimeter. Apply same Coulomb's law, and then after getting the values, we will be able to get the total force as 2.57 into 10 raised to 25 Newton. One is positive, another one is negative, so the force will be attractive in nature. Again, if you want to compare this with your weight, if you are a person of 60 kg now, it is the total weight 588 Newton. On comparison, you can divide the given value by 588.